us now that we have our assets. Essentially now I have a background, two car images, and a blank program that's based off of the snippet for the SDL event loop that comes with EspressoC. Now I've made some changes. Namely, I've changed the code to load the background image instead of clearing the screen to a simple blue. And I've added the code to load the car image as a car1 texture. You'll also notice that I've messed around with the man structure a little bit and added a dx and dy vector, which is going to represent the vector of the car in which direction it's driving in, the velocity vector, and an angle as well, which is an angle in degrees as to where the car is facing. Now in a side-scroller game, typically your code would involve gravity being straight down and the arrow keys going left and right, and maybe up being jump or something like that. However, in the case of this, we want to have it so that the car can be controlled to steer left when you hit the left key and right when you hit the right key, and then have up and down be the accelerator and reverse respectively. So you see here in the code, I've changed the call for SDL render copy that we're used to SDL render copy X, which means that I'm now able to pass the angle of the car in so that the angle that the car is drawn will reflect the angle that the car should be facing. So here's what the code looks like right now with the keyboard not doing anything. You see I have my background in there and I have my car in the upper left hand corner drawn at a pixel double because I think it looks a little cooler to have the pixels be a little bigger. So how do I make this car actually turn left and right? Well, this is the easy part. When I hit left, all I have to do is take the man angle. I didn't rename man the car because I'm lazy, I'm sorry. But I take the angle and I subtract 2 for every time I have left down, and I add 2 degrees for every time I hit right. And what this gives me is the simple ability to at least steer the car. Now I know the car isn't moving in real life, this wouldn't happen, but screw you. I grew up playing PlayStation games that were less realistic, and I think they're more fun. So that's the effect I want to emulate here. So that's the easy part. How the heck do we actually make the car drive in the direction it's facing when we hit up and down? Well, what we need to do in this case is essentially calculate the velocity vector for the car. Now this is a chicken before the egg kind of problem, because if we get the velocity vector right, we actually have to apply it. That's pretty simple. Every frame we're going to take the man x and multiply it by man dx and do the same thing for man y. Also, because there's some friction in this world, we're going to have the car slow down a little bit every frame that we're not accelerating. So for example, if we let off the gas, the car should come to a stop eventually. So what would the code look like to essentially have the car go in the direction it's facing? I'm going to paste it in and then I'm going to explain it. In order to find out the direction the car should be going in x and y independently, we have to use the sine and cosine functions. Basically, the vector that is the velocity vector of the car is the sine of the angle and the cosine of the angle. X is the sine, y is the cosine. Because we're in a vertically flipped world in SDL, I actually negated the cosine to get the right answer for y. And because we are in degrees for the car, I had to convert those to radians because the standard math library, C library functions for math expect things to be in radians. I have some code here that I've minimized, or I will, called mathutil, which I may or may not use for this, that I've pre-written, and in one of those I have a function called radians from degrees, which just multiplies degrees times pi over 180, which gives us the radians that we need. So that will actually have it, with any luck, to have the car actually move in the direction it's facing and come to a rather slow halt when I let off. It's going pretty slow, but that's fine because we're not scrolling and I don't want things to get too crazy too quickly. But already we basically have what we need to have a top-down game. Now I'm just going to add reverse really quickly. You can probably guess what that's going to be. It also would not be a terrible idea to define somewhere, I guess the top of this function is okay, a velocity constant for the car. Float. Well, I'm going to call this speed, actually. That makes more sense. And speed is going to be essentially how quick the car is going when we hit the accelerator or the reverse. So I'm going to multiply the sine and the cosine times the speed to apply that. In reverse, it might make sense to not be able to go as fast, so I might leave these as a constant. But it's important that I negate these when I hold down so the car goes reverse in the right direction and forward in the right direction as well. Yay, he drives around. Now here's where things get a little tricky. I'd like to have another vector that I apply, in other words, another force that has nothing to do with the actual car, but might have to do with forces applied on the car. The quickest one I can think of is when I were to hit these walls, I wouldn't mind actually having the car bump off of them by essentially reflecting off of the wall. So how do I do that? Well, let me go ahead and add my second force. I'm just going to call this GDX and GDY for general force. And that vector is going to be applied, again, every frame to the car's position, like so. G. Eventually, I'd like to have one of these, because one of them is going to represent the car traveling in the direction the wheels aren't facing. It would make sense for the friction to be much higher for that. So maybe in this case, I'd like to actually have the car friction be maybe less in the direction it's facing and more in the direction that's considered general. Because general, it might be bumped in the direction that's not facing the wheels. Now, I know this is a drastic simplification of the physics, because maybe if the car's bumped forward, it should be moving, you know, without friction, but in this case I think it's fine to simplify because I don't want to confuse you guys too much. Really important that when I add one of these, I initialize them so I don't have the thing accidentally set to a wild value. If you guys remember in C, if you don't initialize a variable, it can be like a quadrillion, trillion, or whatever the possible bits were set to, and that would suck. So, okay. Nothing's happened because we haven't set the general force. If I wanted to be stupid and just hard code it right now, I could just say man GDX equals 0.5. He's like, oh, what's happening to me? Okay. So if I remember correctly, when I drew that background image, I showed that, or I made it so that the borders were about 20 off the edge. So in other words, if man X is less than 20, what the hell's wrong with me? Then we should essentially reflect him off of the the wall in the x-axis. So the simplest way I can do this is if there is a GDX and it's less than 0, it means he's going left. We have to negate that value. We actually have to do it again for the standard dx as well, which is the direction he's facing. And that should solve the problem. The most important thing, though, is that we don't want to get stuck in the wall. So we need to make sure that the man x, if he's less than 20, stays that way, or doesn't go any further. So basically, in this case, we need to set the man x equal. I like to add some tolerance in there for how much I want to send him, ensure that he's not going to go through the wall. So let's see what happens. I'm instantaneously setting the velocity here. I should be actually adding to it, and I should be accelerating instead of setting it immediately. So bear with me, because this is where things start to get a little crazy. Now that I'm accelerating the car instead of setting instantaneous velocity, it's going to go really fast. So this speed is no longer a speed, it's actually an acceleration. And because it's an acceleration, I need to really dampen the crap out of it. I'll fix reverse as soon as I fix forward. It's a little better. Okay. I didn't say this was going to be perfect. It takes a long time to dial things like this in, but we're getting there. By the way, it doesn't seem like 20 is the right value for this. I feel like it might actually be something more like 25. So I'm going to do that. There we go. I'm sure if I tried hard enough, I might be able to still get through the wall, but I'd like to move on for the sake of this example here. I would like to make the acceleration just a little bit stronger, though, so because I'm crazy, I'm going to double this. So let's go ahead and do that. Oh yeah, this is awesome. Okay. And now I need to do what I'm doing for the four corners, so I'm going to go ahead and do that really quickly. And I'd like to put that into a function called static void correct. I'm just going to say apply forces. And that's going to take a man as an argument. I'm implying here that maybe I'd like to have more than one man in this quote-unquote game. So doing all this like this is kind of stupid. So here we go. Apply forces, man. Broke that into its own little function. And the man he's dead. Okay. So let's go ahead and do this for all possible four sides here. So let me do the right side here. This would be 640 minus 25. It would be 640 minus 25 plus 5. Let's see what happens. Wait. That's a greater than. How dare you let me make that mistake. Oh, that's right. So when you're on the right side, you actually have to add the height of the car as well, or the width. And we've doubled that, so that's 14 times 2. Let me just put this in here real quick. Const float width height is 22 2. So now we have it's actually if the man x plus his width, then the man x is equal to this minus his width. Oh, these if statements are now flipped. These need to be greater than. Here we go. Awesome. Oh, this is great. Okay. Now it should be impossible, more or less, to get out of this arena, which is what I want. So we're almost done here with our little bumper car experiment. The last thing I want to do is add a second red car, as you probably could guess from the code that I was writing, or the sprites that I made. And I'd like that red car to chase my blue car, and we are going to program on how to do that. And then I'm going to end the video, and you'll never hear from me again. I'm just kidding. But yeah, I'm definitely going to stop the video after that. So, car 2. Car 2 is loaded just like car 1 was. 2, 2. Make sure I free the memory when I'm finished on exit. Run the program, make sure I didn't break anything. So now we have one man, but we don't have one man anymore. We are going to create a second man. Now because I'm a genius, I decided to pass in all the man as an argument into every single function ever. Ideally, that wouldn't make a lot of sense. Maybe I would pass like a game state struct that had multiple objects in them, or if I was really lazy, make them global. You didn't hear me say that. But in this case, I guess I'm just going to finish this the way I started and just add it as a second argument to my main functions here. Because man seems to live as a local variable of the function main, I guess I'm going to keep going with that as well. So when I initialize man 2, he's going to have almost the exact same properties as man 1. So he's going to start in a slightly different position. Maybe across the screen, like so. Then when it comes time to draw the second, well, I better pass these arguments in properly. Man 2, man 2. If you guys want to see how to properly organize things like game objects and actually have this stuff flow much nicer, you might want to check out my C++ series. I talk about how to do like lists and vectors of many game objects and all that polymorphic inheritance stuff. And you want to go into that in this video, because this video is not about that. It's just about how to program something like this, and I don't like to get sidetracked if I can help it. So that's why this might seem a little bit less organized than a typical game might be. Just adding the code here to draw man 2. Okay, let me show him. Let me put him closer to the bottom here. 480 would be, so this actually should be 220, maybe like 520, and this should maybe be like 360. It doesn't have to be perfect. Okay. So what I'd like to do is have, obviously the keyboard's not going to control him at all. However, if I were to crash into him, I'd like our respective forces to push each other back depending on our velocities and our masses. There is an equation to do this like much better than I'm about to do, but I'm just going to go ahead and hack it right now. Yeah, so here we go. This is actually... How do I want to do this? Static void car interior collision. I just gotta call this car collision. Man 2. This function is gonna handle all this. Also, I need to make sure that whatever forces come into effect here, I apply them to the man 2 the same way I applied them to man 1. So far, so good. Nothing's happening. Okay. So I went ahead and borrowed my collision utility from the first video tutorial series. So now we determine whether or not the two objects are colliding by using a function I brought in from the first tutorial series, which is simple bounding box collision. So if man x, man y, width, man x plus width, man y plus height, this is getting annoying to type, 2x, 2y, damn it, 2x, 2y with height. So if that's true, then we know the two cars are overlapping. So what we need to do is we need to find out how, not necessarily how close they are, but the vector between the two so that we could essentially push them away from each other with that general force I was talking about. And this is going to have to do with the speed and some other things as well, but the long and short of it is we need the vector between the two of them. So Vx is equal to man y x, sorry, man 2x minus man x Vy, man 2y, man y. That's the angle from the man to the second man. So that angle should be negated and applied to the man's general force. So g dx plus equals Vx, g dy is equals the negative Vy. Alright, so let's see what happens when we run this. So when I get close enough, I'm really bounced far away, and that's simply because the vector that I'm applying is not normalized. So I have a really nice utility function here called normalize, which will normalize the vector for me, make it unit length. So now when I apply this, it'll be a lot less worse. Now what I'd like to do, which would make the most sense, is have it so that at least the force that I apply to the opposite car is equal to the speed, or at least proportional to the speed of my own force. So that I can do, right? I can make it so that if I wanted to move the red car when I hit it, I could do essentially the opposite force applied to the red car. So now instead of negating the vectors, I leave them as so. And the red car should be pushed away when I crash into it, which it is. Now the force that I apply to the red car ought to be proportional to the speed that I'm traveling in. Well, how do I know my speed? It's not necessarily given to me, or I don't store it anywhere. I essentially put it into that vector I have. So what I need to do is get the length of the vector of dx dy of the car that is assaulting the other one. This actually goes both ways. So this Vx is going to be multiplied by something proportional to man 2's speed, and this one's going to be for man 1's speed. So in order for me to get my speed, I essentially need to take the length of man dx and dy. Okay, so in order to get the speed of... I take his length... dy. Do the same thing for man 2. Then I multiply, let's see, like so. Now I don't want these to end up letting me go through if they're small enough. So essentially, if this is too little, I want to leave it as a reasonable value. So I'm clamping these to 1 at the very smallest that they could possibly be. Okay. This is kind of ridiculous, but basically seems to be working more or less. So how do we make it so the red car actually chases me? So this is the part that took me forever to get to, but is actually more simple than just about everything else we've done because it requires just one function. There's a special function called atan2, which converts a vector in Cartesian or just standard square coordinates to polar coordinates so that we can get the angle that we need for one object to face another one if we have the vector for it. So essentially, this code right here that gives me Vx and Vy, if I take Vx and Vy and input those into atan2, we will be given the angle that man 2 needs to face man 1. So let me show you what I mean. So here's Vx and here's Vy. All I have to do to get the angle in degrees, or, oh great, I'm going to have to reverse my degrees. That's great. To get the angle in radians, for man 1 to face man 2, all I have to do is call atan2, pass the y first, so the y and then the x component of Vx and Vy, and I should have my answer. Now, because I am in radians, I actually need to convert this to degrees, which would simply be just calling degrees from radians on the result of atan2 and setting man 2's angle equal to theta, and maybe this will work. So right now it seems like he is facing 90 degrees to the right of me at all times. So this is simple. If I just subtract 90 degrees from this, I should have the right answer. See how he's sitting there in a very menacing way, always facing me no matter what. So all I have to do now, which is kind of silly, is just always have the red car accelerate, and in a very annoying fashion, he will always be driving into me. So let's do that. Same way I have code here. To move the car when I'm facing up, I'm going to just always assume that the red car is facing up. Oh my god. That is so annoying. There's nothing I could do. Now, I know my collision detection isn't perfect, but this is only about an hour or two of work. When you're doing these kind of games, usually you will have some form of polish that you'll add to make it so that the glitchiness isn't so bad. But this isn't a bad start for like an hour. So this is how you program a top-down, or at least the beginning of a top-down car-like game, complete with really, really annoying AI. So I hope you guys enjoyed this. This makes it worth it. I was getting frustrated earlier, but in the end, this makes this really like totally worth it. So I hope you guys enjoyed watching this video tutorial, and I'll make the code available for this soon enough. Thanks for watching, guys. Bye.